Okay, so let's start with number 42. And in 42, it is asking us to find f or g of f of x. And so when we work this out, what this is asking us to do is take our function here, x squared, and substitute that in for x. So we see that g of f of x is going to be 1 over 4 minus x squared. So that is going to be answer choice F. Okay, for 43, it would be good for us to know the formula and the relationship between the circumference of a circle and the area. So we see that the area is equal to the circumference squared divided by 4 pi. And so that would be something good to remember. And then if we sub in, we have 2 pi root 2 all squared over 4 pi. And then we can continue on with our work. We have 4 pi squared, and then the square root of 2 squared, that's just going to give us 2. And that is all over 4 pi. And so notice that we're going to get some canceling here. The 4's will cancel, and one of the 2 pi's will cancel. So it looks like we're left with 2 pi. For number 44, we have a function defined to be y equals f of x, and we have a y-intercept on this graph of 0, -2. Now we need to know what is the new y-intercept if we take our function and subtract 3 from it. Now remember, f of x is really your y values, so what this is saying is, what are you going to get for your y's if you say y minus 3? Well, y is -2, so -2 minus 3, that's going to give you -5, so that's going to be answer choice F. Number 45 is asking us which of the following would be the equation of the parabola that would go through the given points. Now something for us to realize that now a parabola, that's going to be a U. And notice from, well, God bless our little drawing right there, but notice that from the way that we have to connect our points that are given, our U is upside down, so that automatically eliminates answer choices D and E because we have to have a negative value. Now the next thing that we need to look at in our answer choices, if we had a value squared, that means that my graph would have bounced on the x-axis, and I don't have that graph. The bounce would have been, we would have touched here and then turned and gone back up. We would not have crossed, and we don't have that case, so that's going to be answer choice A. Number 46 is saying that they want us to reduce this down, and how we need to think about it is that x is getting really, really big top and bottom. So whenever this happens, this is really talking about a limit value, but you don't have to know the calculus to do this. It's x over x plus 3. So again, don't worry about the calculus. This is growing without bound. In other words, we're approaching infinity, and this is approaching infinity. So both of these are growing in the same direction. They're both growing without bound. So that little plus 3 becomes very insignificant as x gets bigger and bigger and bigger. So this is really going to become 1. Okay, so for 47, we have a good probability problem. And notice that what we want to happen here, we have 30 marbles in the bag. And so we're drawing 2 marbles from a bag. And we want to make sure we draw a black marble for the first, and anytime you see the word and, you need to think multiply with your probability. So I need to get a black marble and a green marble, and you're not replacing the first marble. So the number of black marbles we have is 6, so I know 6 out of the 30 times, and then I need a green marble, which is going to be 2 of the remaining 29. And the rest of that's just good calculator work, and that's going to end up giving you answer choice B. Number 48, we are defined when the denominator equals 0. So we have to say b minus 2c equals 0. And so we will add over our 2c, so b equals 2c. So that's going to be answer choice K. Okay, so for number 49, we want to know which number is halfway between our two fractions. So we're going to just add our fractions and then divide by 2. And a quick way to add fractions, if you don't have your fraction calculator or fraction key on your calculator, you can cross multiply plus cross multiply here and all over the product across here. And so that's going to give me 54 over 35. Now keep in mind that we do want to divide that in 2, so I'm going to multiply that by 1/2, and so that's going to give me 27 over 35. So that's going to be answer choice E. Now for the next problem, we want to know what two real numbers is going to make this whole function equal to 1. Well, the only way I can change a 3 to a 1 is make sure my exponent is 0. So that means I need to take what I'm given, my x squared minus x minus 2, set that equal to 0, and now we need to factor. And notice here when we solve for x, we get 2 and we get -1. So that's going to be answer choice H. Okay, so this problem we're looking at the foci for the ellipse, and the foci is going to sit on your major axis, which is going to be the longer of the two. Now this is your minor axis, this is your major axis, and notice here for the center, that's going to be 3, 5 is your center. So the foci that they're wanting us to find is sitting somewhere here and here. So notice that we need to have the same x value, so that's going to eliminate here because we know we're going over 3 something and 3 something. So here we need to find out what that distance is. So and it looks like we can get rid of answer choice E because they're going to both be 3. So to find out what that distance is, that's going to come from the denominators here. To find that foci, you're going to take the square root of the difference in the denominators. So that's going to be the square root of 16, which is 4. So that means I need to add 4 and subtract 4 from 5. So if we do that, that's going to give us answer choice D. Number 52 is a good probability problem. And notice what it's asking us here. Red or have a 3 printed on it. So whenever I look for all of these different numbers, notice we have 10 solid colored balls in the bag. So what we're going to do is see, well, how many red do we have? And it looks like they gave us 3 red, so I have 3 of the 10 are red. And notice it says the word or. Or is going to imply addition. So or, and now I need to see, well, 2 of the 10 could be have a 3 printed on it, but now we have to subtract, and what we're having to subtract would be the fact that we have a ball that might repeat. We could have a red ball that has a 3 on it. We have 1 out of 10 chance of getting that. So we need to subtract that out because it's already been counted once and we don't need it counted again. And so notice that's going to give us 4 out of 10. So that's going to be answer choice J. For number 53, we need to find the area. And everyone likes to fall over on the area formula of 1/2 base times height, but we don't have enough information in this problem for that. So we need to go to the less common used formula, which is going to be 1/2 AB sine of angle C. And so we know that because I have 2 sides and I have an angle given to me. So when I go through to work this out, the area is going to be 1/2 times 13 times 12 times sine of 30 degrees. And you can type that straight into your calculators, or you can work it out by hand if you need to. That's 1/2 times 13 times 12, and sine of 30 is 1/2. And so when you finish working that out, that should give you answer choice B. All right, number 54, strange problem. So we have 66 calories in 15 grams of Parmesan cheese, and 59% of that is from fat. And as we read through the problem, I would pay attention to my units. I need fat per tablespoon, and tablespoon is usually capital T, teaspoon is lowercase t. So I need fat per tablespoon. So what we need to do is go through and look at our conversions. We have 66 calories for 15 grams. Okay, so we also know 59% of that is from fat. So to kind of get our fat grams, 59% or 0.59 of 66 is going to generate our fat grams, and that I would definitely type in the calculator. That's going to give us 38.94. So that's going to be fat. And then notice we need 5 grams is equal to 1 tablespoon, but I have 15, so that's going to be per 3 tablespoons. And notice if we divide that out, that is going to be about 12.98. So the closest value is going to be J. It's going to be 13. Number 55, we need to know what percent of the area is represented in the shaded portion. Now we're told that the triangle, this whole big triangle here, that is 1/4 the actual area. So that we already know that portion being 1/4, we know that is 25% of the original. Now this little portion in here, this is dividing our square in half, and then we're halving that half with this little portion. So really I need 25% of 25%, and that's going to give us 0.0625, and that as a percent we move our decimal 2 places, so we're going to get 6.25%. So that's going to be answer choice D. Number 56 is really more of a reasoning problem. You have 10 distinct values, and then you're going to take the single largest value and replace it with an even bigger value. So which of the following is going to be true when you compare the mean and median? Well, you're not adding anything to the set, so you know the median should stay the same. So, and notice that here for everything, the only option that you really have left to choose from is going to be F and J. But if you're really increasing that other, or the biggest value, you're increasing that more, then the mean will also increase. So that's going to be answer choice F. Number 57, notice that your answer choices are all set up like a matrix. Now something for us to remember with matrices, you will take your row, and I need to change the colors here. You're going to take this row and you multiply it to this column, and you need to make sure you end up with the outcome you need. So notice that for your schools, let's see, for select students you have $5 for the teacher and $3 for the student. So all of this 5 and 3 would be your teacher and student. And then you have in one school 1 teacher and 10 students. So you need to be able to multiply 5 times 1 and add that to 3 times 10. And that's what you're looking for to happen when you multiply matrices. And then the next one, notice you were told that you had 2 teachers and 25 students, so you need 2 teachers times $5 plus $3 times 25. And it just so happens this first one that we're looking at, that does happen. Notice both cases are happening here. So that's looking at it from your matrix point of view. Now number 58, with that one, you're given just some abstract information. And I would use the fact that 5 arrow down is going to be this. So I know 5 arrow down is going to be equal to, let's see, what are we going to get there? 5, 10, 15. Now, which of the following is going to always be true for all positive integers? So let's see about this one. All right, so I'm going to use the example, let n be 5. And so here I'm going to have 5 arrow down, so that's going to give me 15 plus, well, n was 5, so 6, so that's going to give me 21. Is that the same thing as 6 arrow, which is just adding 6 to 15, so I get 21. So I know this one is correct, so that eliminates those. So all we need to do is check one more. Don't go through all 3. That's craziness. So let's look at the next example. N arrow down, so I know that's going to be 15 plus n arrow down. So that's going to give me 30, and they want to know, is that the same thing as saying 2 times, and our n value was, not 10, our n value was 5. And so we want to know, is this going to generate the same stuff? Well, 10 arrow down. Well, we know 6 is going to be 21, right? So we're going to add 7. Let's see what value I get here. So I'm going to start, let's see, that's going to be 10 plus 9 plus 8 plus 7 plus 6, but I know from 6 down is 21. And immediately we see we have more than 30, so we know that's not going to be right. So my answer choice is F. For number 59, we are given that this person is going to cut off these edges, and they made a nice little box that has a volume of 72 cubic inches. So that tells me 72 is equal to length times width times height. Well, we're told that we need to know the original cardboard. What were the dimensions of that? Well, we know the height is 2, so I can go ahead and substitute that in, and we see that 36 is our length times our width. Now, notice that we've just cut off these edges here. This portion inside is still a square, so that portion here is really the bottom part, which is going to be your length and your width. And it's a square, so it's the same thing. They cut off the same amount on each side. So really I can say, well, W is the same thing as the length. So 36 is equal to L times L. So that tells me L's got to be 6. So the length here is 6. Now keep in mind, they cut off 2 from each side. So 6 plus 4 is 10. So that tells me the original box was a 10 by 10. All right, and on number 60, some things that might be useful for us to remember. This is really just 1 plus I. And we have some properties. If we square 1 plus I, we get positive 2I. If we square 1 minus I, we get negative 2I. That's pretty useful for you to remember going into the ACT. It may or may not pop up, but you never know. Now, knowing this, why do I say that's going to help? Well, which of the following quadratic equations has complex number blah as a solution? That means when I plug in, I should get 0. So I'm going to get plug in equal to 0. So let's take F. Let's take x squared. Well, x squared, I know it's just going to be 2i. It's 2i plus 1 equal to 0. Well, no, it's not. What about this next one, G? That's going to be 2i plus 1 plus I plus 1. Nope, that's still not going to give us 0. Well, H is looking a little bit more promising. So I have 2i minus x, so that's going to be minus 1 minus I plus 1. Well, we're getting a little bit closer, but it's not going to be that. And notice if you continue with this process of elimination, you're going to end up with answer choice K.